On October 28, 2012, urban centers along the U.S. Mid-Atlantic and Northeast coastlines operated under standard late autumn conditions. New York City's subway system moved 5.4 million passengers daily through tunnels positioned below sea level. Electrical substations serving 8.5 million people occupied waterfront locations designed under 20th-century flood projections. Coastal building codes reflected statistical hurricane probability models that classified the region as low-frequency impact zone. Tidal infrastructure assumed maximum surge events would not exceed historical measurement from the 1821 and 1938 storms. Metropolitan transportation networks had no precedent for simultaneous shutdown across multiple states. Barrier Island communities housed permanent populations, with road access dependent on single bridge connections. The Northeast urban corridor between Washington, D.C. and Boston contained 36 million permanent residents in 2012. New York City electrical distribution relied on 57 substations, with 13 positioned at elevations between 0 and 3 meters above mean sea level. The Metropolitan Transportation Authority operated 660 miles of subway track, 47% of which ran below grade in tunnels vulnerable to flooding from surface water intrusion. Coastal communities in New Jersey, New York, and Connecticut occupied barrier islands and peninsulas where elevation averaged 1 to 4 meters. Regional power generation utilized centralized transmission crossing waterways via bridges and underwater cables. Urban drainage systems processed stormwater through gravity-fed networks designed for rainfall events, not oceanic surge. Population density in affected zones exceeded 10,000 people per square kilometer. No major hurricane had made direct landfall in the region since 1985. Tropical Storm Sandy formed over the Caribbean Sea on October 22, 2012, with initial wind speeds of 75 kilometers per hour. By October 25, the system had intensified to Category 3 strength, with sustained winds of 185 kilometers per hour while tracking northward along the Bahamas. On October 26, the cyclone began interaction with an upper-level trough positioned over the eastern United States, initiating structural transformation from tropical to hybrid morphology. Storm diameter expanded from 480 kilometers on October 24 to over 1,600 kilometers by October 28, creating the widest Atlantic tropical cyclone on record. Wind field expansion occurred as central pressure deepened to 940 millibars. The system maintained tropical characteristics while incorporating mid-latitude energy, producing sustained gale-force winds across a 1,500-kilometer span. Satellite analysis documented cloud structure covering area equivalent to 1/3 of the continental United States. On October 28, numerical weather models projected an unprecedented westward turn toward the New Jersey coastline, diverging from typical Atlantic storm tracks that curve northeast into open ocean. The shift occurred due to atmospheric blocking pattern positioned over Greenland and eastern Canada, preventing northward progression. Landfall timing aligned with astronomical high tide scheduled for evening of October 29, when lunar phase created maximum tidal elevation. Historical storm tracks affecting the region had arrived during low tide cycles or at reduced intensity. The combination of westward approach angle and tidal peak had no analog in instrumental record dating to 1851. Storm forward speed decreased to 37 kilometers per hour as it approached land, extending duration of wind stress on coastal waters. The track brought the cyclone's right front quadrant, the zone of maximum surge production, directly over the most densely populated coastline in North America. Storm surge reached 4.28 meters above normal tide at the Battery in Lower Manhattan at 9:24 p.m. on October 29th, exceeding the previous record of 3.24 meters from Hurricane Donna in 1960. New York Harbor's funnel shape amplified incoming water volume, compressing surge into progressively narrower channels. Wave heights of 9.9 meters were recorded at offshore buoys 26 kilometers south of Long Island.
Coastal New Jersey experienced surge values between 2.7 and 3.9 meters, with localized measurements reaching 4.2 meters in Raritan Bay. The Hudson River estuary reverse flowed inland for 19 kilometers. Long Island Sound documented surge heights of 3.1 meters on the Connecticut shoreline. Total water volume displaced into New York Harbor exceeded 15 billion cubic meters. Surge arrival coincided with high tide at 8:55 p.m., producing combined water elevation 4.9 meters above mean low water in some locations.
At 8:31 p.m. on October 29, saltwater entered Con Edison's East 13th Street substation in Manhattan, disabling electrical distribution to 250,000 customers. By 9:47 p.m., 7 additional substations in Lower Manhattan had flooded, cutting power to the area below 39th Street. Saltwater contact with 13,000-volt equipment caused short circuits and transformer failures. The company implemented preemptive shutdowns in coastal zones of Queens, Brooklyn, and Staten Island, removing service from 945,000 additional customers by 10:15 p.m. Total power outages across the metropolitan region reached 8.5 million customers by midnight. New Jersey utilities reported 2.7 million customers without electricity. Grid restoration required equipment replacement rather than simple reconnection due to saltwater contamination of copper wiring and transformer oil. Some substations remained non-functional for 13 days. Peak simultaneous outage represented largest power failure in New York City history.
At 7:30 p.m. on October 29, the Metropolitan Transportation Authority suspended all subway and commuter rail service, removing 5.4 million daily passenger capacity from operation. Surge entered subway tunnels through ventilation grates, station entrances, and trackway portals beginning at 8:45 p.m. 7 underwater tunnels connecting Manhattan to outer boroughs filled completely with seawater, including the Clark Street Tunnel beneath the East River, which reached 30 million liters of water. The Montague Street Tunnel flooded to ceiling level across its 930-meter length. Hugh L. Carey Tunnel, formerly Brooklyn Battery Tunnel, filled with 326 million liters of seawater in 90 minutes. Electrical substations powering signal systems and ventilation were submerged. Total water volume entering the subway system exceeded 227 million liters. 8 bus garages flooded, disabling 1,200 vehicles. Commuter rail service on Long Island Railroad and Metro North ceased with flooding of East River tunnel approaches and New Haven Line electrical systems. Hurricane Sandy's wind field and surge affected coastline from South Carolina to Maine, spanning 1,500 kilometers. All 5 boroughs of New York City experienced power outages, transportation shutdown, or structural damage. New Jersey coastline sustained surge impact across 210 kilometers, with barrier island communities isolated by bridge and road failures. Connecticut shoreline documented flooding in 31 municipalities. Over 650,000 homes in New York and New Jersey lost electrical service for more than 7 days. Regional fuel distribution systems failed as flooded terminals prevented gasoline delivery to 65% of service stations. Blizzard conditions occurred simultaneously in West Virginia and western Pennsylvania, with 91 centimeters of snow accumulation. Storm effects persisted across the region for 72 hours. Air travel ceased with closure of Newark, LaGuardia, and Kennedy airports from October 29 through November 1, canceling 19,729 flights. Official casualty count attributed 147 direct deaths to the storm in the United States, with 72 occurring in New York and New Jersey. Approximately 2.1 million people experienced residential displacement lasting more than 1 week. New York City public housing complexes lost power, heat, and elevator service, affecting 400,000 residents, some for 16 days. Hospital evacuations relocated 6,400 patients during the storm and its immediate aftermath. Sewage treatment plant failures released untreated wastewater at 23 facilities. Saltwater inundation damaged 88,000 buildings in New York City alone.
Barrier Island communities, including Breezy Point, New York, and Mantoloking, New Jersey, documented structure destruction rates exceeding 50% in specific zones. Fire consumed 126 homes in Breezy Point when storm surge disabled water mains. Insurance claims eventually exceeded 450,000 filed properties. Economic impact assessments totaled between $65 and $70 billion in damage and lost economic activity. Subway system dewatering began November 1, requiring industrial pumps to extract 227 million liters from tunnels and stations. The Montague Street Tunnel required 14 days of continuous pumping. Electrical infrastructure restoration prioritized replacement of saltwater-damaged transformers and switchgear. Con Edison deployed 11,500 workers to Lower Manhattan restoration, completing primary service return by November 10. Metropolitan Transportation Authority restored partial subway service on November 1, with full network function not achieved until May 2013 due to signal system replacement requirements. Barrier Island road access restoration required temporary bridge construction and debris clearance lasting through November. Federal disaster declaration covered 12 states. Emergency response personnel totaled over 91,000 from multiple agencies. Temporary housing programs relocated 28,000 households pending structural repairs. National Hurricane Center final report classified Sandy as Category 3 at maximum intensity and Category 1 at New Jersey landfall on October 29 at 7:30 p.m. local time near Brigantine. The World Meteorological Organization retired the name Sandy from future use in May 2013. NOAA's damage assessment determined it was the second costliest tropical cyclone in U.S. history after Hurricane Katrina. Federal Emergency Management Agency distributed $15.4 billion in disaster assistance. Post-storm engineering analyses documented surge return period of 500 years for Lower Manhattan based on statistical modeling. Infrastructure modification programs initiated in response included barrier systems, subway floodgates, and electrical substation elevation. The event became reference case for urban coastal vulnerability studies and climate adaptation planning frameworks.